Hello, a very good evening from Physics for Students. My name is Shaunak and a warm welcome after a long time. Just let me know, am I audible? Those who are watching me, can you please let me know? Because there was some problem with my mic, so I don't know whether you can hear me. Let me know whether I'm audible or, or not. I think I'm audible, right? Just send me a yes or no in the chat box so that I can understand. Am I audible? Uh, okay, so I think I'm audible. Is to study physics, and so I physics study. Now I'm reading quantum physics and have a YouTube channel, physics. Okay, so send me the YouTube channel link so that I can subscribe and increase your watch hours also. Yeah, success boys. Very good evening. Okay, so I think I'm audible. So what I would do today is that I've got a range of books, I mean to say, which I would like to give you an idea that what are the type of books starting from the basic classical physics and going up to the advanced level. And also before that, what I would like to show you is that you really don't need to come to me, okay? Because I want to give you a solution through which you can understand that whenever you are purchasing a book, Physics by Nikunj Vyas. Okay. So Nikunj Vyas, am I audible? Is it all okay? Can you see? Can you hear me out? Right. So what I was saying is that let me give you an idea or some tips and solutions that you cannot go every time to anybody and tell that okay, is this book good? Which book? Which? Okay, thank you. Which book I should go for, etc. Rather, there should be a solution through which you can know that okay, if I'm selecting a book, if I'm purchasing a book online, or I am doing anything, then these tricks or these techniques should help me to select a good book. See, I always feel that you should not waste your money in purchasing one book, two books, three books, and then go and then, oh, sir, I really don't know which book to go for. So, initially, what I would like to show you is this one that on the 2nd of June, Professor Surojit Chattopadhyay, he is from the Department of Mathematics, Amity University. So those who wants to build up a career in mathematics, pure mathematics, applied science, cosmology, etc., you can be there on the 2nd of June, 8 p.m. on my channel, Physics for Students. He is basically considered as one of the 2% of world scientists as done by the Stanford University survey. So if you want to make your career in mathematics, which book to read, what are the problems, shall I take up career as into mathematics, how I can be a theoretical physicist, all the questions you can ask to Professor Surajit. He is a very nice person. He is very reputed worldwide. I don't know whether you know his name. Go and search in Google. He is considered to be one of the scientists in the world survey done by Stanford University. Okay, so don't miss this one. 2nd June on my channel. Okay, next thing what I would like to tell you quickly, and then we will go forward with the books, is that you please identify your learning goals. I mean to say for example, if you're learning physics, say for example, this person, yes, Nikunj, you can definitely mail me. My email ID is contact.physicsforstudents@gmail.com. Okay, I'm flashing this on my screen so that you can get this one. Okay, you can obviously mail me, WhatsApp me, whatever the way you want to get in touch. I always help students. So the thing is that you need to identify your learning goals. That means my goal might not be that I want to learn physics in order to do mathematics. I just want to relax and read a little bit of quantum mechanics and a little bit of Big Bang. My goal might be that I want to solve mathematical problems so that I can do the examination better. So different people have different objectives, and for that there are different types of book. So you cannot say that okay, this book is meant for all. So that is why I have written identify your learning goals. It can be reference books. You can see the screen, right? So let me know if you have any question. You can learn the history of mathematics. It can be popular mathematics. It can be theories and proofs, and it can be software guides like MATLAB, etc. So whenever you are selecting a book, whenever you want that, okay, I want to purchase this book, ask yourself that what is my reason. Say, for example, I was just talking to my father that my old Redmi Note 4 is no more working. Okay, my mobile. So now I want to purchase a mobile. So shall I go for an iPhone, or shall I go for a OnePlus, or shall I go for a 40,000-50,000 rupees mobile, or shall I stick to 20,000 rupees? What is my objective? If my objective is making videos, shooting high resolution videos, making YouTube shorts, I have a different video mobile in my mind. Similarly, in the book, try to identify what is the goal. Are you trying to solve history of mathematics, popular mathematics, whatever? So when you try to identify what goal you have in your mind, then go for the bookshop, then bargain, then take up the price that I want to purchase this book. So everybody has different objectives. So try to understand what objective you want. This is very important. Assess your current level. That what I'm trying to mean by this is that all books do not have the same level of understanding. Say, for example, today if I want to learn differential geometry and I'm starting with the book of Prasun Kumar Naik, I won't be able to understand. Why? The reason is that that book takes up to a certain level of understanding, and then it goes into making you understand about differential geometry, tensor analysis. So what I have to do? Okay, I don't know much about tensors. I just know the initial of vectors. So I have to go to a book which will build me upon. So this point is very important. Assess your current level and then select the book. All books are not meant for everybody. Some of them are advanced, some of them are easy. So you need to understand which, first of all, your objective, that I want to do mathematics, I want to get good in examination, and then what is my level? Do I know all those things that this book assumes? I will show you examples of book through which you will going to understand. So please remember this one. Obviously, you need to read reviews and recommendations, because Amazon is okay. Flipkart, I don't know. I have never purchased book over Flipkart. I mostly go for Amazon, Amazon CO and Amazon US. So go for good reviews and recommendations. Understand what the reviews are telling. Again, the person who is writing the review can be a mathematician. Are you getting my point? Please do react in the chat box. So if a mathematician is telling that, okay, this book is great, that does not mean that that book has to be great for you, because you are not a mathematician. Maybe you are studying at the master's level or a bachelor's level. I hope that is clear. So the recommendation which is being given by the person over Amazon, you need to check who is the person who is giving. Is it a layman or is it a general person who is giving? So just remember on this. So these are the few points which has to be there: credibility, the content and depth, clarity, engagement style, core, scope and purpose. I will explain you quickly what are those things. Okay, this is very important when you are selecting a particular book. What is the book structure and content? That means how the book is organized. You will see there are some very good books in mathematics. I would say pure mathematics, group theory, ring theory, real analysis. The content of the book is superb, absolutely great. But the organization of the book is made in such a haphazard manner that you are not being able to understand. So the structure of the book, how it is organized, that is also important. So, for example, logical progression and organization. So, is it logical that instead of jumping to step number 5, it is going to 1, 2, 3, 4? I hope you get my point. What are the essential topics that they are covering? Exercise and practical problems. Are there sufficient exercise? Again, these exercise will be useful only for those who wants to do the exercise so that you can get good score in your class, in your examination. But if I just want to read what is Big Bang, what is black hole, what is wormhole, what is white hole, exercise and practical problem is not meant for me. So that means it is not necessary. So what is your objective? Again, going back to point number 1, that is important while you are selecting a book. Are there enough examples? Are there enough pictures, photograph and illustrations? Are there pedagogical features and support? Pedagogical features in the sense that how you are going to teach, what is the method of teaching, etc. Because if you're selecting the book that after reading this book, I'm going to make it as a teaching, then there has to be a pedagogical support. You must have seen, I went to Orissa a few months back and I made a video standing on the sea beach, a YouTube shorts, where I told that this video on the waves of the ocean can be similar to that of waves on physics. So the teachers should take the students out on the sea beach, and then they should teach them what is amplitude, wavelength, etc. That is called a pedagogical instrumentation, pedagogical use. That means I'm using waves of physics to go to the ocean near the sea beach and teach. So those things has to be clear. Okay, there are a lot of good books that uses brevity. Brevity means in a computer. I'm a computer scientist in quantum mechanics class, and I feel a bit lost. Do you have advice? Brain in a shell. Okay, so computer scientist in quantum mechanics, and I feel okay. So which level brain in shell you are, and why you are feeling a bit lost? Is it that in the class the teachers are going fast? That you need to identify. Is it that you can type it out? I can answer right now because I am live over here. So is it that the teacher is telling very fast? That you need to tell me. If the teacher is teaching very fast, then either you have to tell the teachers that, okay, sir, hold on, I'm not being able to understand, or you have to do a little bit more study before going into the class. I will tell you, my daughter, she is in class 9. She also, I mean to say, she is not a computer scientist, but young students, they feel lost when they go to the class. There may be a lot of reasons you're not being able to understand. The teacher is teaching fast. The teaching method is not what you want. So you need to identify what is the reason that you are feeling a bit lost. Then you tell me over WhatsApp or email. I will definitely help you. This is my job. For the last 10 years and 12 years, I'm doing this, guiding the students so that they can do mathematics and physics in a better manner. Right? So brain in a shell, I would say that why you are feeling lost, what is the problem, connect to me over email or anything and let me know, then I will help you. So try to get a book that avoids brevity. Brevity means that there are a lot of books which takes all the things in a very short fashion, in a short manner. And for example, let me show you. If I say the derivative in calculus means rate of change. Now, a person who is first learning calculus won't get it. If I say the derivative of a function measures how its output change as its input changes, then it carries a meaning. Are you getting my point? So what I'm trying to tell is that there are many books who tries to make things in very short, maybe to avoid the number of pages or printing cost, whatever. Don't go for these books. Don't go for these books. If you are a self-learner, then you should go for books which are much more elaborate, which talks a lot of things. Again, an example. Okay, fine. Something that changes the motion of an object. Now, what does it mean to change the motion of an object? Does it mean to make the object faster, slower, or in a different direction? So try to avoid those books which are telling everything in a very short way. If it is telling in a short way, then you might not understand initially if you are a beginner learner, something like that. Okay. So that is why it brings us to the next point. Go for a book that assumes you know nothing. So I always tell that go for a fatter book, not for a thinner book. You might say, oh, this is 900 pages book. Then it will be very difficult for me. How will I read those 900 pages? But I can tell you fatter books are easier to learn than the slimmer books. Okay, why? Because slimmer books uses all those, short words, abbreviations, which becomes very difficult for you to learn. So try to get a book which contains a lot of descriptions and explanations, etc. Okay, theory of sir, I am a 10th grader. I am studying quantum mechanics, but sir, the mathematics that is in the quantum mechanics weird. Can you recommend some cheap books for whole mathematics, almost all section, including mathematical tensor? Okay, so this is a very good question. First of all, what I would like to tell you is that I have got a very big playlist. Let me give it to you. Look into this playlist. Who is the person? Theory of everything. Go for this first. I have sent it in the chat box. It contains almost all the mathematics that is required for quantum mechanics. Okay, so if first of all, if you are studying mathematics, that is the in the quantum mechanics is weird. Okay, cheap books. Okay, So I don't understand the concept. Okay, not Maverick, I will come to your question. Just hold on. Let me first understand, answer theory of everything. So go for this playlist, theory of everything. I think the theory of everything, if you can spell me out your name, I would be happy to call by your name. So this is a pseudonym, I think. So this playlist will give you a complete idea. Okay, if you want to go for a very cheap book, I would suggest Gilbert Strang, or even if you have a financial problem, you can contact me. If I have got the soft copies of the book, I will send it to you. Don't worry. Don't worry. I try to help at my best. Okay, so Gilbert Strang's linear algebra. This is a very good in terms of quantum mechanics. So what was your question? I'm studying quantum, but sir, the mathematics that is the quantum is okay. This is a very good book for Gilbert Strang's linear algebra. Go for this playlist one by one. I can tell you, if you go for the playlist, all the things of quantum mechanics will be covered. Okay. Another thing is that you can take up any good book on probability theory, any good book. Ng Das, okay, let me type it out. It is a cheap book. Ng Das, okay, you can go for Ng Das book on probability. I can tell you, for the quantum mechanics part, theory of everything, you need primarily two good mathematical tools. One is linear algebra, one is vectors and linear spaces, and another is probability. That's it. And most of the things I am covering one by one in that playlist. You can just go one by one, you will understand everything. If you cannot, do let me know. Okay, coming to North Maverick, sir, I don't understand the concept of instantaneous velocity, or in general instantaneous rate of change. How can a change occur in a single moment? Okay, very good question. Okay, so the thing is that North Mavericks, I don't know your name. So instantaneous velocity, see, when I mean to say, okay, let me, do I have something? Okay, let me go to my paintbrush and I will just tell you what it is. It's a good question. It comes as a problem for most of the young people who are learning that. Okay, so can I share my screen now? Let me see. Yeah, let me see. Okay, how will I share? College level classical mechanics, as you might know, linear algebra. I will come to that. I will come to that. Just hold on for a second. Present, share screen, this one. Okay, I hope this part is visible now. Okay, so instantaneous change in the sense is that, for example, if a body is moving in this way, say for example in this pattern, okay, this is not very much visible. How will I change the depth of it? Yeah. So if I'm making a change like this, say for example, this is a body. I take any body which is over here, okay? And if this is the change which is happening right over here, that means this is a change. Try to understand it in this way, that if this is a change over here and this is a change over here, okay, time is, say for example, t0. I'm so sorry, I know that this is a little bit weird because the brush etc is not that thick. Let me see if I can make it a little bit thicker. Yeah, so if the time over here is, say for example, t equals to 0 and time over here is t equals to 2, then if this body is accelerating from here to here, say for example the velocity is 1 and then it comes 2, then it becomes 3 and then it becomes 4 and then it becomes 5 and then it becomes 6 over t2. So if the body is changing from here to here, I am trying to make initially the velocity of this entire path, this path for example. But what if I quickly want to check the velocity instantaneously over here? Instantaneous means I'm not taking the initial and the final, just this one, this portion. What is the change? So say for example from 4 to 5 it has changed in this path, then instantaneous velocity maybe at this point is 4.2. Are you getting my point? Please let me know. And maybe this path has also changed from this part to this part, whatever the velocity has been from 10 to 12. And if I pick up a small part instantaneously here, Instantaneous means immediately, just at that moment, particularly how things are happening, right? So that is actually what is called an instantaneous change. Or what you are asking is that, yeah, how can a change occur over a single moment? And that is why the importance of calculus starts, because try to understand that when I am taking a kind of a change, where is my screen? Yeah, so when I am taking a change from here to here, okay, let me draw another one. So I'm taking a change from here to here. In case of discrete mathematics, I would get a change here and a change here and a change here and a change here. So these are all different, this change and this change and this change. But whenever I'm using calculus, that means I'm using dy by dx, I'm differentiating or integrating, whatever. That means between this point and this point, there are 1001 small points like this. Between this and this, again, there are 1001 point this. And I'm just, what I'm doing is that I'm picking up one particular point, this one, or maybe this one, or maybe this one. And I'm trying to calculate the instantaneous change at that particular point. I'm not considering the entire trajectory. I'm not considering it. I'm just considering that particular instance. So is that clear to you now? Is that clear to you? Please do respond. Who was that? North Mavericks. I hope I can make things clear. That is called an instantaneous change. Okay, college level books of classical mechanics, assuming I know algebra and real analysis. I will just tell you, I am coming to that point. Karan Nalawan, sir, whenever I take a break in mathematics, I forget a lot of things. So it is common to forget in mathematics. Do you have any advice? Yeah. So Karan, the thing is that if you are taking a break in mathematics and if you're forgetting, then I doubt that you are using too much of social media. I see, I will tell you, I was going through a research report. Don't take me wrong, right, Karan? You are a son, almost like my son, age of my son. So I would say that it is telling that nowadays, because the youngsters are all doing shorts, swiping up the shorts for about 10 minutes, 15 minutes, leading to memory loss. It is leading to memory loss because it is telling that the moment you are starting swiping those shorts, that means your brain is getting a kind of a training that you cannot retain anything in your brain more than 20 seconds. So short is coming, it is going. Again, it is coming, you're going. Again, it is coming, is going. So what is happening? What is happening is very deadly to young people. And I can tell you this is going to ruin the career of young people. That is, you are unable to remember. In our days, forget about smartphone. Even still, I watch a very long video of 1 hour, 20 minutes, and I take notes and I remember. But I am also getting things like if I watch too much of shorts, which I don't generally, but Instagram, Facebook, this is leading to memory loss. And it is scientific. It would lead to memory loss. The reason is that you are not training your brain to hold something for 1 hour. Forget 1 hour, 20 minutes. Have you seen this video of mine? I don't think you are paying attention. I made a very serious video for young people. I know the views really do not here watch it. What I would suggest all of you and Karan Nalawat is to watch this video. This is called the Pomodoro technique of understanding mathematics. That means 25 minutes of short time, you learn and remember certain things. Take a 5 minutes break. Increase that 25 minutes to 30 minutes, increase that break to 40 minutes, increase that to 50 minutes. In this way, try to concentrate on your studies without looking at your mobile, social media, not talking to your friends, girlfriends, whoever, for 1 hour, and then take a break of 10 minutes. Nowadays, the social media, the entire internet is programming human brain in such a way that tuck, 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 gone, 1 minute. More than 1 minute, people are unable to remember. So Karan, I would say that this might be a reason that you are watching too much of social media, etc. And or maybe you are not practicing. So if you write and practice, definitely it is going to come. Sir, how shall I start with classical physics or quantum physics? Very good question, Saad Khan. So Saad, just wait for a minute. I will just give you the names. Can you suggest books for physics.net syllabus? Unfortunately, I don't have the Ajitra, the names of .NET because I don't deal with competitive examination. My specialization is mostly into MSc and PhD mathematics and physics. So yes, Ajitra, you have my email ID. You can write to me. I will consult with my students who are into physics.net syllabus and I will give it to you. Okay. So try to go for books. I will come to Saad just a moment. I have got a lot of books, so I'll quickly finish this off. This is also important. That has a holistic approach. That means if the book is, say, for example, in classical mechanics, quantum mechanics, whatever, then it gives a kind of a summary. So we have learned the major components of this, then this, that it should give a holistic approach to that. So points to keep in mind, what is the big picture, all those things. Thanks so much, sir. I'm a beginner of calculus. A lot of concepts are kind of crazy. Yeah. So North Mavericks, what I will do is that I am starting a new series of videos on absolute beginners calculus. So it will give you a lot of insights. I will start with what is a function, what is a domain, and then I will move into differentials. So it will carry a lot of prerequisites of calculus. What are the things that you need to know in order to learn calculus? And then we will go for that. Okay. So North Mavericks, thank you for coming. Okay. Go ahead for books that has schematic diagram summaries. These are good things. This will help you to understand, because there are many books which do not have any diagrams, especially for physics. I won't recommend you to go for that books. A book that review background materials. Now, what do I mean by review background materials? That means, for example, just now, who was the person who told me theory of everything? He just told me that I am getting confused in the mathematics of quantum mechanics. So mathematics of quantum mechanics, if you're getting weird, that means you don't have the knowledge of the earlier mathematics. What is that? Maybe vectors, trigonometry, linear algebra, determinant of matrices. So whenever you are selecting a book, try to get these points clear. The book, does it have a historical context? Because without history, you won't be able to understand anything in terms of either physics or mathematics. Does it give you a review? That means, okay, so in order to learn quantum mechanics, you first need to have an idea of trigonometry, basic algebra, linear algebra, etc. And if you don't know those things, then that book gives you an idea. Are there special boxes, small boxes, which gives you a review? So, okay, so we understood this. Cross references. So from algebra to trigonometry, from trigonometry maybe to harmonic analysis, whatever. And there should be some online resources. This is not actually much required, but if it is happening. Okay, a book that emphasizes only on basic concepts, not on peripheries. That means there are a lot of books you will see that keeps on talking about a lot of other things rather than the basic concept. So that is also not good. And book that have exercises with a proper return on investment. These are, you see, problems and exercises which have given. So these books give you a proper understanding. A book should have small tips rather than larger ones. That means, say, for example, you learned 10 or 5 pages, then it gives you a summary. Another 5 pages, another gives you a summary. Instead of learning 20 pages and giving a summary, it is better that you have things step by step. Uses concrete and simple examples, and you should not have book that says it is so simple, it is so obvious, it is so trivial. No, these simple or trivial, obvious, what does it mean? That this book assumes that you know certain things. As I told, that book should assume that you know nothing, zero, and starts training you one by one. And that is the reason I tell that selecting a fatter book is better than the other. Okay, now I will come to what is called the best book in terms of classical physics and classical mechanics. Just hold on. Let's just have a sip of water. So how are you finding today's live session? No comment, nothing. You're just asking questions. We're meeting for a long time. Okay. So classical physics, the first book I would recommend is this one. Okay. Halliday and Rensick. This is a 906. No. It is a 1,000 page book, and it contains almost everything that you need to know about classical physics. No questions asked. There cannot be any book which is better than this one. Fundamentals by Physics of Physics by Halliday and Rensick. This is absolutely a wonder. Look into the content, what it covers. It is so detailed. It is so detailed and so simple. It uses billions of examples. It starts first with measurement, then motion, then force and motion, kinetic energy, gravitation, rotation. Then it goes into volume 2, electric fields, Gauss's law, and it goes up to energy, Maxwell's equations, nuclear physics. So if you are really wondering that what book shall I start for with classical physics, this is the book for you. This is another book in classical physics which you can go, Tai L. Chow's book. This is also very good, and this is equally very exhaustive. As you can see, it starts with kinematic and describing in motion, Newtonian mechanics, integration of Newton's equation of motion, Lagrangian. I mean to say, it is not as simple like the earlier one, but yes, this is a very good book. Classical mechanics. Okay, Tai L. Chow's book. This is also a very good book. These are the two books which I would recommend. One is that Modern Classical Mechanics and Theoretical Minimum by Leonard Susskind. So I think you should start first with this book. Okay, first go ahead with this book, and then don't go for this book. Go for the Theoretical Minimum, then go for the Modern Classical Mechanics, and then go for this one. This is a little bit advanced in the sense that this book would be, I mean to say, gives a lot of mathematical formulations, but this is the gem. I have read it many times. I use it for my own videos, notes, etc. There cannot be a better book than, if you are a self-learner, even remember that you're learning on your own self, that you don't have a tutor, you don't have anything, you just know the basics of mathematics, then this book would be the golden book, the Bible. You should keep it in your shelf. Okay, if you're looking for something in abstract algebra, there are students who question me that what are the books, sir, which I should go for abstract algebra. First, go for this book. This is an absolutely wonderful book by Charles C. Pinter. So it will first give you an idea what is abstract algebra, then what are groups, then subgroups, functions, groups and permutation, etc. To start with abstract algebra, I think this is the best book for abstract algebra. I mean to say, again, if you're a self-learner or you know the basics of mathematics, you can go ahead for this book. Next comes these two books which you can very well pick up. Abstract Algebra by John B. This is the first course, and Contemporary Abstract Algebra by Gallian. Contemporary Abstract Algebra is a little bit, I would say, on the application part of abstract algebra in terms of research, etc. But this book, John B.'s book, First Course in Abstract Algebra, is a very good book. So first go for this book, then go for the second, and then go for the third. So these are good books, easy books. Lot of exercises are there. Here in this book, there are a lot of exercises. I've just given these, chapters, but there are many more chapters. So here you can see what is the content of this book. So integers and equivalence. Then it goes for groups. It's a very good book. Rings, etc. I mean, say it's great. You can learn it easily. I would come to calculus, ordinary differential and partial differentials. So again, I would consider this is a self-learning book, as you understand that there are a lot of self-learners nowadays. So first go for this book, Thomas Calculus. Now, why I am telling you Thomas Calculus to go for before going out for any other group, there is a reason. Now, again, as Theory of Everything was telling, I have seen many students who actually jump into calculus without having the knowledge of what are the things that you require before calculus. I mean to say, you know function, you know algebra, you know Pythagoras' theorem, you know everything, but at times you will see you get confused, and then you will feel I am lost or I am not being able to understand things. So that is why this book, primarily Thomas Calculus, again, it is a more than 1,000 pages book. This book will give you on the preliminaries of preliminaries of calculus. You can see here, first it talks about functions, okay, trigonometric functions, graphic functions, inverse function, logarithms. You might say, sir, we all know, but yes, fine. You know that is great, but why don't you revise it one more time? Then it goes into limits and continuity, derivatives, etc. This is a well-organized book which has got boxes, etc. Tremendous. I can say you, this is the golden book for calculus. Applications of derivative. Then it got the integrals, definite integral transcendental function, first order, infinite series, and everything. This is a very detailed book, gives a lot of illustrations also. So you can go ahead and get this book. So after you complete this first book, Thomas Calculus, you might find that a lot of things you already know. But I'm suggesting this book. Why? Because there are a lot many people who might know or might miss on certain preliminaries. So I think this would be a good book. After that, you can go for this one, Sylvanus P. Thompson's Calculus Made Easy. Not much of integral calculus or integration exercises are there. This is a very simple book just to get an hangover of the idea of calculus, differentiation, integration, as well as PDEs. If you are much more seriously now going into the mathematics of calculus, you can go for this book by Piskunov. This is a classical book. I would say it's a very classical book which we read in our college days. It's a Russian book. It's contained a lot of mathematics and differential calculus by George Osborne. This is a very old book, but still considered to be one of the best. Coming to partial differential equations, if you want to go, then this book would be good. Peter J. Oliver's book is very good. And then you can go for Yehuda's book, Partial Differential Equations. And this one by Johannes is also goes partial differential equations, but it introduces the mathematics of Maple, etc. So definitely. So for calculus, this would be the first book to go. And then you can go for Sylvanus Thompson, Piskunov, and partial differential equations. This would be the book. I would like to come to what is called complex analysis. The first book, I think I have already made a YouTube short on this book, which is called Complex Analysis with Applications. Oh my goodness, this is one of the best book. I think even a class 8 or 9 student can start learning complex analysis. This is by Dennis G. Zill and Patrick G. Shannon, a first course in complex analysis. This is absolutely wonderful book. Then you can go for this second book, which is Titu Andersu and Dornick Andrika, Complex Numbers from A to Z, and then Yvonne Stewart's book. But this book is good enough. I mean to say, the complex analysis, the first one, this is good enough. Okay, so someone was asking, Saad was asking, that classical physics, Saad, as you can see, I have covered. Quantum physics, I have divided into two parts. One is called lighter reading, and one is a serious reading. So lighter reading is also good. I would first suggest you to go for the book of Manjit Kumar, the middle one. Okay, Quantum, Einstein, and Bohr. It is absolutely amazing. These books are not mathematical in nature, right? So if you're expecting a lot of mathematics, linear algebra, wave function, probability, no, it doesn't contain. But it gives you a lot of history, insights, life of scientists, how things are going, etc. in quantum physics. So first, the middle book, not the left one. Sean Carroll's book is, don't take me wrong, I won't suggest it. Right, although I have given over it, but this book is very good. Quantum Physics by Quantum Einstein Bohr Debate. This is by Manjit Kumar, and then you can go for this one, Beyond Uncertainty. This is also a very good book by David C. Cassidy, and then you can go for Shaw Carroll's book. So not much of mathematics, but a lot of interesting, light reading, good books on quantum physics. Serious physics, I would say you can start with Griffith. But I would recommend the blue one, A.C. Phillips Quantum Mechanics. After going for many years through a lot of books, I still feel Leonard Susskind's book and A.C. Phillips' book is good enough. Obviously, R. Shankar's book is tremendous, but it is again, contains a lot of mathematics. Good book about R. Shankar is that R. Shankar gives you a lot of understanding of the classical part of quantum of the physics before he goes into quantum physics, the wave functions, etc. So R. Shankar's book again does not assume you everything. So you can start with the blue one, A.C. Phillips, then you can go to Leonard Susskind's book, then go to Shankar's book, and then come to Griffith's book. Okay. Now, because quantum physics is something which is revolving around Schrodinger equation, I think I have made a video on the best book on Schrodinger equation. This is a very good book, again by Daniel Fleisch. Daniel Fleisch obviously is one of the greatest writer of physics book, vectors and tensor, etc. So again, this is the book to learn Schrodinger equation. Again, it assumes nothing. You don't need to know a lot of mathematics. These books make you prepare. So the good part of this book is that it starts with vectors, then it goes into linear algebra, then it goes into probability theory. So it gives you a complete understanding of whatever is required for you to learn the Schrodinger equation. Okay. These are some of the good YouTube videos. Yes, I would suggest you to go for this. What is the Schrodinger equation? Then Parth G, one of my friend, he has also got a very good, can you understand this? Then this Dr. Dave, he has got a very good book on, sorry, Professor Dave, yeah, Dr. Dave on quantum physics, etc. So these are very good YouTube videos. Can you recommend some books for covering net physics syllabus? So I told you, Ajitra, I really don't deal with the net program. But yes, if you can email me, I will look into it and let you know. Okay, so the last one, which is by Brian Greene. This is a tremendous series of videos which contains a lot of mathematical explanations, and he is live teaching on Schrodinger equation, on general relativity, and a lot of other stuff. So you can go for this. Somebody was asking me, sir, what is the best book that you can go for thermodynamics? I think one of my subscribers was asking about thermodynamics. So I would recommend one simple book, and this is the Bible. I think, again, a class 8 or 9 person can learn thermodynamics. This is by Eunice Sengel, Michael A. Bowles. It's a classical book. It is 963 pages, again, because it's our books for electrodynamics covered in classical physics. Very good question, Rajavandran. Yes, classical electrodynamics, if I talk of that first book of Haley's, that part is being covered. But yes, you can get in touch with me, Rajavardhan. I have certain exclusive books for classical electrodynamics. So if you are thinking to learn classical electrodynamics in a very specialized manner, then these books are not giving you a complete idea. There are specialized books on classical electrodynamics. I will let you know. No problem. This is a good question. I have certain books in my laptop, also soft copies, which I go for my classes. So classical electrodynamics, in that sense, no book is covering in classical physics. There is one book, Mir Publishers, Moscow, I don't remember. That was the only book which covered classical electrodynamics. Otherwise, you have to purchase a separate book for that. So this is an excellent book in thermodynamics. Old book, very old book. It is very organized. Forget about this, but one thing is that there are no solutions to this questions. So you cannot find the answers also. But it is an excellent book of thermodynamics. I mean, it's amazing. Coming to vectors and tensors, I would say first go for, so those who really don't know anything about vectors or tensors, Daniel Fleisch books, which I have recommended many times in my videos. This is a very good book on tensors, but it is not mathematical in nature. But yes, it is good. Okay, yeah, thank you. It is a great introduction. So it will teach you right from the basics of vectors, advanced vectors, vectors operation, tensors, one dimension, two dimension tensor, metric tensor, general relativity tensor, tensor analysis, etc. But it is not very mathematical, but it's a good book. This one you can go for GE vectors, GE Hayes vector and tensor analysis. This is also a very good book. This one also a little bit older one, Borisenko and Tarapov's book, is very mathematically excellent. Does not contain any printing mistake, etc. So almost all the areas are covered in this part. If you are willing to learn tensor calculus specially and only for physics part, then this person, German, Neun Schender's book on tensor calculus is good, because after going through vectors and tensors of Daniel Fleisch, then you can move over here. But here the problem is that it is not as simple as this one. So don't expect that it would give you a very easy explanation. So it assumes a certain level of mathematics, but yes, it is very good for physics. And I always recommend this book. This is one of the best books. This has got no alternative, tensor calculus and differential geometry by Prasanna Kumar Naik. So Professor Prasanna's book is more about differential geometry. And the beauty of this book is that Sir, books for atomic and molecular physics, as I'm taking all this in astrophysics by Baidyanath Basu's book. Okay, yeah. So for atomic and molecular physics, again, exclusively SSJ, if you want that, then you have to go. But for atomic and nuclear physics, okay, nuclear physics, I will tell you. Hold on. Now, I have got a book. Just be there. I will just look into that. I have got a book on nuclear physics. We are talking of nuclear physics, right? Modern physics. I have to actually search. Just hold on. Yeah. Let me share the screen so that you can see this one. Okay, can you see the screen? This is a very good book on nuclear physics. Okay, this is a good book. Why? Because I will tell you, if you go through the content of the book, so you see here, let me zoom it. So you see chapter 1 has got relativity, then chapter 2 has relativity and gravitational physics, then quantum physics. This contains a lot of nuclear physics. It's a long book, so I would have to show you one by one, which I don't have the time. So here you can see quantum mechanics in 3 dimensions, statistical, molecular structure, solid state, nuclear structure, nuclear physics and application, elementary physics. So this gives you a fairly good idea about what is the content. This is a absolutely great book which contains solid state physics, molecular structure, statistical physics, atomic structure. I mean, say modern physics. Now you see the number of pages are 682. So this is a very good book in terms of going through the modern physics and the and this one. So I hope this will give you the answer. Okay, so this is the one which would be good, and you can also go for Robert Seward's book on Introduction to Vector and Tensor Analysis. Special relativity, if you want to understand special theory of relativity. Okay, sir, I will read this. Okay, thank you. Yeah. So special relativity, this is a very good book by Sardesai, Indian author, and it is called a primer of special relativity. That means what you need to know before learning special theory of relativity. So simple and right up to the point. Lot of exercises are there. Then you can go for this book, Space Time by Wheeler and Taylor. Again, this is not a mathematical book, so it will contain for absolute beginners just an overall idea with a little bit of mathematics, etc. Not a very much good mathematics. Yes, this would be a very good book for special relativity. If you want to go through, you can. This is by Springer, Michael Samperlis. Michael Samperlis is actually a physicist, so it is very good, but you need to know calculus, vectors, and linear algebra. So those who do not know that, obviously in special relativity is assumed that you know those things. This is again a very good book by Leonard Susskind's Special and Relativistic and Classical Field Theory. Now you see, this is the only book which talks about classical field theory. Remember, classical mechanics and classical field theory is not the same. So you need to really know about classical field theory, and there are many books which you can talk to me later about classical field theory, because from classical field theory, the concept of field theory emerges, quantum field theory, general relativity, which is again a field kind of a physics, etc. So this is, I'm actually making I think it will be a good video, a detailed video on what are the basic concepts of quantum field theory. So it will just tell you what are the basic concepts of quantum field theory, and why do we need, what are the limitations of earlier theories that led to the foundation of classical field theory. So that's all. I mean to say, I showed a range of books starting from classical physics going up to, yes, I have not covered general relativity, differential geometry, topology. This again I can cover up there. So before I leave, I want to thank you for those who are constantly supporting me on my channel. And today also, I can see around 9, 10, 11, 12 people, but that is fine. I have not been regular, but today is Wednesday. So I will again try to come online on Friday. I was suffering from some eye infection, health problems. A lot of examination papers are coming these days for me to correct. After coming to from college back to home, also again I have to get my examination papers, corrections, etc. So I was not getting time. But yes, thank you, SSJ. I really miss you. I really miss those live sessions, which I know I should do. Actually, my plan, I will tell you, this year is that I'm making a great, I should not say myself great, but I'm making a series of videos on general relativity and differential geometry, chapter by chapter. I don't know whether you will take it seriously or not, but this is going to be a great piece of video making, because I'm going through the history of general relativity, and thanks to the artificial intelligence, Gemini and Chat GPT, I am reading the original manuscripts of Einstein, how he struggled, what are the problems that came up, and through that, how he actually framed general relativity. So I have already made two videos: story of general relativity, part 1 and part 2. You can go through that. And also differential geometry, I'm taking up one by one. I am planning to start a new series on tensor calculus, thermodynamics, and general calculus. I mean to say ordinary and partial differential calculus. So I hope that is okay. You don't have any questions. And Ajitra has asked me about .NET syllabus. So you can email me later, and I can tell you what are those things. So any further questions, or we can say goodbye to all of you. Okay, so no further questions. So I hope I can make it on Friday around this time, 8:30 to 9:30. Let us talk on something else. Let us decide. Or you can also tell me or suggest me a topic in the community box of my channel, Physics for Students, that what could be a very good discussion point, and we can start discussing on that. Thank you very much. Take care. Goodbye, and keep on your spirits high and keep on learning physics. Do contact me, do WhatsApp me, do email me, because I love to be disturbed by students. Take care. Yeah, goodbye. Yeah, SSG, goodbye. And whenever you are sending me an email, just mention that you came in a live session. Otherwise, I won't be able to understand, because there's so many names. Thank you very much.